I just marked this dragon. This is a piece of stainless steel, and it's just a piece of junk stainless that I pulled off an old industrial machine. So nothing special. I don't know exactly what grade of stainless it is, but whatever's the cheapest, that's probably what it is. So the settings I used to mark this was 150 millimeters per second speed, 10% power, and 40 kilohertz frequency. And the hatch was a line distance of 0.05 millimeters, and that was at 0 and 90 degrees. So I'm going to try the exact same thing, except I'm going to change the hatch distance to 0.005 millimeters. And let's see if we can get a darker mark. So it's going to go right next to it right there. So the settings that we're going to use for this mark are a speed of 150, power 10%, frequency of 40 kilohertz, hatch of 0.005 millimeters, and an angle for that hatch of 0 degrees and 90 degrees. That's 2 passes. So this should produce a black mark, but it won't have much depth to it. It'll just be mostly a superficial mark, but it won't be anything so light that you can rub it off. This mark is by far the slowest in the entire video. I'm going to mark 5 or 6 of these dragons, and then at the end I'm going to mark a grid similar to the grid I've marked in the past on other materials if you've seen any of my other videos. But this does produce some of the best results for pure clarity. You can see there's a bit of a color shift, especially on the first mark that was more of a white mark on the stainless when you do change angles. So you can see, looking at the screen now, that I did write with a fine tip Sharpie exactly what settings I'm using for each mark, because I figure I'm going to mark this several times, so it'll be a little bit easier to remember and identify each mark. So the big difference between the current mark and the previous mark is mainly the color, and we've got that through the lower power setting on the previous mark of 10%, and the current mark is happening at 20%, and the hatch, which I think is a big deal. So the previous one was 0.005 millimeters, the current one is double that at 0.01 millimeters. And you can see once this is done that it doesn't quite fill in as much, so you don't have as much clarity, and the mark isn't quite as uniform. Not quite as dark, but deeper. Feels deeper. You can feel that mark. This is much, well, you can feel that, but it's a little more of a surface mark. That's difficult to feel. So with the goal of trying to achieve the same results as the second dark black mark, I'm going to try to speed this up a little bit and mark it 200 millimeters per second and 25% power, same frequency, and change the hatch spacing to 0.02 millimeters. I don't think this is going to be very dark, but it's worthwhile as an experiment. The only change that I did make is to go 0, 90, and 315 degrees, so 3 different hatches. And I'd call that one a gray mark. So I'll put a picture up here of the first 4 marks so you can see them up close. This is just a straight on angle. You can kind of see what the hatch spacing does, what the power does, what the frequency does. Well, I guess I didn't change frequency, but everything else you can see how those changes in variables affect the result. So this one we're going to do at a much higher speed. It's going to be 500 millimeters per second. We're going to up the power all the way to 50, lower the frequency down to 25. So I believe that should be more destructive and vaporize more material. Hatch is going to be all the way up to 0.03 millimeters, and we're still going to do the 3 different hatches. So this is going to be pretty quick. I'll leave this in real time. So you can sort of see the results shaping up as compared to the second mark we made. That would be the first black mark up top. It's not quite as shiny, so it's not quite as pretty, but it is happening pretty darn fast. Now there is a little bit of a brownish hue to it, and that seems to be what happens with stainless when you use too much power and go too fast. You do lose some of the darkness on the shift though. Now you see a half finished mark on the screen, and that's because I changed my settings by writing them on the stainless steel physically, but I didn't actually change them in the computer before I started the mark, so I stopped that one partially through and X'd it out, and let's just move those settings over to the one we're currently marking, and that's what applies to this. So we're going to increase the speed to double, 1000 millimeters per second. We increase the power to 60%. The frequency is now all the way down to 20 kilohertz. The hatch is all the way up to 0.05 millimeters, and we're still doing the three angles of 0, 90, and 315. So the upside of these settings is that the total marking time is only 31 seconds, so pretty fast. The downside is you can see it's pretty brown. So if you're looking for a black mark or a silver mark or even a white mark, then these settings are probably not the right approach. So I posted a couple other videos in the past where I used this grid of power versus speed just to get an idea of how a certain material will mark, and I did this previously on aluminum and copper, and I wanted to see how it would look on stainless. So I'm going to fast forward through this because we don't need to see it marked, but the end result shows that the lower power settings tend to show a white mark, and the higher power settings, really anything over about 30% power, starts to get dark, which is kind of a stark comparison to aluminum, because if you recall, aluminum didn't get dark until about 40% power with my laser. So this one has a kind of a steep curve, but you can see it's very brownish up on sort of the top right quadrant of this grid. So playing with the settings, marking dragons, and marking this grid kind of helped me get a sense of how a material is going to react to the laser, and hopefully they can help somebody else too.